Now let's begin with the construction of a tangent to the circle. A. Construct the tangent to a circle at a point on the circle. Look at the figure. Here, line L is intersecting the circle in point P. Thus, line L is a tangent to the circle at P. Point P is called the point of contact. Segment OP is the radius of the circle. As the angle OPB makes a right angle, measure of angle OPB is equal to 90 degrees. It means that the tangent is perpendicular to the radius. We will use this property for the construction of a tangent at a point on the circle. Thus, a tangent to a circle is perpendicular to the radius at the point of contact. Now let's solve an example. To construct a tangent to a circle of radius 3.2 cm at a point on it. Now let's look at the construction. Draw a circle with center O and radius 3.2 cm. Take any point P on the circle and draw ray OP. Draw the line L perpendicular to ray OP at the point P. Name that line L. This will be the tangent to the circle. Before we begin, let us recall the property of angles in alternate segments. If a line is drawn through an end point of a chord of a circle and an angle formed by it with the chord is equal to the angle subtended by the chord in the corresponding alternate segment, then the line is a tangent to the circle. Let us use the above property for the construction of tangent to the circle without using center of the circle. Look at the figure. Here, consider PQ as chord PQ. Let A be any point on the circle other than points P and Q. Draw segments PA and QA. If line PN is a tangent, then by tangent secant property, then the angle formed by a tangent and a secant at the point of contact is equal to the angle in the corresponding alternate segment, that is, angle QAP is congruent to angle QPN. Now, conversely, using QP as one side and P as vertex, if we draw angle QPN such that angle QPN is congruent to angle QAP, then the line PN must be a tangent. Now let's look at an example. Draw a circle of radius 3.5 centimeters. Take any point K on it. Draw a tangent to the circle at K without using center of the circle. Draw a circle with radius 3.5 centimeters with point K on it. Now draw chord DK. Take any point A on the alternate arc of KXD other than K and D. Draw segments DA and KA to join triangle DAK. Now taking a convenient measure on compass, keep the points of compass on vertex A and draw an arc passing through sides AD and AK. Use the same measure and at vertex K, using DK as one side, draw an arc bisecting side DK. Now, cut the arc drawn from vertex K, taking the measure of arc of angle DAK. At this point of intersection of arcs, draw ray KS, extend it to form line KS. The line containing ray Ks is the tangent to the given circle. Let's solve an activity. With the help of a bangle, the circle is drawn. How to construct tangent to this circle? Which properties will be used? Why? Answer. Look at the figure. We have a circle here with center O drawn with the help of bangle. Now take any point P on the circle and draw ray OP. Draw the line L perpendicular to ray OP at the point P. Name that line L. Thus, we have constructed tangent to this circle. Here, we have used the property called a tangent to a circle is perpendicular to the radius at the point of contact. We use this property for the construction of tangent at a point on the circle. Now let's see how to draw tangents to a circle from a point outside the circle. We have studied that the angle inscribed in a semicircle is a right angle. We shall use this property to draw a tangent to a circle from a point outside the circle. Let's draw a circle with center O and radius R. Take point P in the exterior of the circle. Through point P, we can draw two tangents. Let's recall the property of tangent, that is, tangent is perpendicular to the radius at its outer end. From the figure, it is clear that we have drawn right-angled triangles. Let's recall the property of circle and right angle, that is, an angle in a semicircle is always right angle. Angle subtended by the diameter is right angle. Here, we need two right angles. So, consider OP as diameter, then angle OAP and angle OBP will be the same and those angles will be right angles. Let's look at an example. Construct tangents to the circle of radius 2.8 centimeters from a point at a distance 6.5 centimeters from the center. Let's begin with the construction. Construct a circle with center O and radius 2.8 centimeters. Take a point P such that OP is equal to 6.5 centimeters. To find the midpoint of segment OP, draw perpendicular bisector of segment OP. Now, we got the midpoint M of segment OP. Now draw a circle with center M and radius MP. Let A and B be the points of intersection of these two circles. Draw lines PA and PB, which are the required tangents. Now let's begin with exercise 3.2. Question 1. Draw a tangent to a circle of radius 2.9 centimeters and center O at any point M on the circle. Solution. Draw a circle with center O and radius 2.9 centimeters. Take any point M on the circle and draw ray OM. Draw the line L perpendicular to ray OM at the point M. Name that line L. This will be the tangent to the circle. Question 2. Draw a circle with center P and radius 3.1 centimeter. Draw a chord MN of length 3.8 centimeters. Draw tangents to the circle through points M and N. Solution. Draw a circle with center P and radius 3.1 centimeters. Draw a chord MN of length 3.8 centimeters. Now, draw rays PM and PN by extending the radii PM and PN. Take a convenient length of PM and PN, keeping the point of compass first on point M. Draw two arcs bisecting ray PM, then draw similar arcs from point N bisecting ray PN. Take more than half length of the distance between the arcs and draw two intersecting arcs below and above points M and N. Now draw perpendicular lines A and B to rays PM and PN respectively. These perpendicular lines A and B are the required tangents to the circle at points M and N respectively. Question 3. Draw a circle of radius 3.5 centimeters. Take any point K on it. Draw a tangent to the circle at K without using center of the circle. Solution. Draw a circle with radius 3.5 centimeters with point K on it. Now, draw chord DK. Take any point B on the alternate arc of K, X, D other than K and D. Draw segments DB and KB to join triangle DBK. Now, taking a convenient measure on compass, keep the point of compass on vertex B and draw an arc passing through sides BD and BK. Use the same measure and at vertex K, using DK as one side, draw an arc bisecting side DK. Now, cut the arc drawn from vertex K, taking the measure of arc of angle DBK. At this point of intersection of arcs, draw ray KS. Extend it to form line KS. The line containing ray KS is the tangent to the given circle. Question 4. Draw a circle of radius 2.7 centimeters and draw chord PQ of length 4.5 centimeters. Draw tangents at P and Q without using center. Solution. Draw a circle of radius 2.7 centimeters. Now, draw chord PQ of length 4.5 centimeters. Take any point A on the circle as shown and draw chords PA and QA. Now we got triangle PAQ. Keep point of compass first on A and draw an arc passing through chords PA and QA. With the same measure and side PQ as one side, draw arcs from points P and Q bisecting chord PQ. Now draw ray PM such that angle PAQ is equal to angle QPM. Then draw ray QN such that angle PAQ is equal to angle PQN. Thus, the lines containing rays PM and QN are the required tangents. Question 5. Draw a tangent to the circle with center O and radius 3.3 centimeters from a point A such that distance OA is equal to 7.5 centimeters. Measure the length of tangent segments. Solution. Draw a circle with radius 3.3 centimeters with center O. Now, take a point A such that distance OA is equal to 7.5 centimeters. To find the midpoint of segment OA, draw perpendicular bisector of segment OA. Now we got the midpoint M of segment OA. Now draw a circle with center M and radius MO. Let X and Y be the points of intersection of these two circles. Draw lines OX and OY, which are the required tangents.